What's up, fam? Back at it again. Let me give you some time to take a guess at where we are right now. We're back at it again. That's where we are. Um, Today I learned about what did we learn about? Um, I learned about counting sort today, another sorting method. Pretty cool. Linear time sort, my first linear time algorithm. So I want to go back to the question that we had yesterday, I think it was sorting. No, the sorting question. And I want to try and implement this counting sort bullshit. Difficulties, let's just go for the easy ones first. I don't know. Uh, I really don't know. Let's go for, let's just pick a random one. Boom. Sorting the sentence. What the fuck is this? Okay. Leading spaces. Okay, I don't want to do this. Yeah, I don't want to do this. What I want to do is just pure sorting. So I'm just going to go back to the question that I did yesterday, which is sorting just this one. I think it was just this one, right? And I didn't actually solve it. You must solve the problem without function O n log n time complexity, right? O n log n meaning you should probably use like a quick sort or whatever. But today I learned about counting sort, so I'm just going to try and implement that, right? So the first thing you want to do is you want to make another vector, if I'm not mistaken, uh, which is size. So first thing you want to do is you want the size of the vector. Um, and the second thing you want is you want the max of the vector. Um, and to get the max, you want to include algorithms. Algorithms or algorithm, forgot. CPP max element. Algorithm. Okay. Um, right? And then you go star, standard. I guess you don't really need that here. And then nums, nums dot begin and nums dot end. Right? That will give you the max. And then now what you want to do is you want to create another vector of size. Okay, hold it. Create another vector of size plus no max plus one, because let's say original vector has like is five, right? But realistically the range is fixed because there could be uh zero in there as well, right? Assuming that it's all positive, right? Assuming that it's all positive. Um, um, Okay, this gets a little annoying. Does vector negative indexing C++? Can we do that? Okay, we can't do that. So what we can do is move all the elements uh, up, um, which I haven't learned yet, which I have not learned yet. So what do we do here? Um, okay, can we look for another question that I can actually do? Let's go counting sort. Sort by. Mm, is there a counting sort lead code problem? Yep. Okay, here we go. I want to practice these. Let's say that. Given an integer array nums of 2n, group these integers into pairs. Okay, so there's a sum of mm, how does this work? 1, 2, 3, 5, 6. And then the second step is counting the frequency of each thing. Hmm, very interesting. Oh, I see. Okay, yeah. Because if like once you sort it, then you just return every even indice, right? I believe so. I believe so. But the numbers can be super negative. That's a thing. Yeah. Yeah. I know it's sorting, but How do I implement counting sort with I sort once with because there could be negatives, right? There could be negatives. And if that is the case, then mm, okay, okay. Um, it has to be even numbers. It has to be even numbers, and I could technically just sort it, right? I want to know if this is right. Algorithm again, right? So I want to know if the logic is right. Um, then I will go, right? Then now it's sorted, and then will be zero. And sum for I, I is smaller than num stop size. I plus two, because I only want the even ones. Sum plus goes to num I and sum. Don't know if that works. Time limit. Yep, the sum say then I return the sum. It should be say, right? Yeah. How would that be a runtime error? I mean, how would that be a time limit exceed? I really don't understand, to be honest. Like, what? Why is it so slow? This seems like a pretty simple algorithm, no? How is this so slow? What? Oh, or is it? Okay, maybe it's a network issue. Wait, it could very well be a network issue. Hello, hello. Yeah. Wait, okay, maybe it's not. Wait, is it? No. I understand all the even indexes of a sorted one. You could break it into you can break it into a merge sort as well, and then always return the left branch. I don't know how to do all the recursion thing right now. Like I really need to think about it. I don't really get. What? Hmm. I know, but why is this wrong? How is this so slow? That's what I don't understand. 嗯嗯，我充個先出去，我做緊嘢噶，我可以唔充啊？我會充去充，係啊，嗯我唔 get 點解佢咁慢喎，即係 why is it so slow？ Let's look. What's different? What is different? Huh? Because I didn't do this? There's no way. There's no freaking way. Okay, so literally this doesn't work. Yeah, this is literally the same as my solution. Is it not? Is it is it that? Is that the problem? So that is the problem. Wait, wow. Interesting. Oh, wait, so it's a for oh, I fucked up the for loop. What the fuck? So it was stuck here. Okay, I'm dumbass. Well, I got it then. I did get it. Um, what? Select the belonging. Oh, yeah. Wait, I'm sorry. I'm sorry. Okay, I did get it. It's just fuck this up. Just stupid. Yep. Okay. Sure. Sure. I got this one, by the way. For sure I got that one. What about these? It's too long. I'm not reading that shit. Okay. For each nums alpha, how many numbers in the array are smaller than it? Okay, this is a counting because it's given the index, right? Length. Four would be at index zero, five would be at index one, six would be at index two, eight would be at index three. Okay, this is yeah, okay, this is a counting thing. Because in the counting array, because in the counting array, in the counting sort, in the second array would be the counting array, and the counting array the position of gives the position in the output array of where the value should be, right? So let's say the value of you're looking at is four, and and in the position of the output array, number four would have a position of five. Then number four would have an index of four, right? Because it's the fifth position and its zeroth index in the vector. So if it has a position of five, it would have an index of four, right? Something like that. So I just have to what I have to do is I have to implement the counting algorithm here. Sure. Okay, I will do that. Nums. So this is what I'm looking for. Yes. Um, okay, there is an easier way to do this. I don't actually have to do this. I just thought of it. Okay, let's say sort, right? And then nums dot begin and nums dot end. And then I have one, two, two, three, eight, right? And then I will let's say I make a new vector, right? New vector and I call this copy equals to nums. And then I will sort the copy array, right? One, two, two, three, eight. And then now I'll initialize another copy of just an empty It's an empty vector, empty vector. And then I will push back. Oh, what am I pushing back? I'm pushing back uh so for nums, right? For in I equals to 0, I smaller than nums dot size, uh, plus I. So I'll loop through all the elements. And then what I have to do here is for every element in nums, I have to return the index of nums in um, in in copy, right? So I'm assuming I use at, right? Mm, right. Okay, that's not what I need. I need the inverse of at. So it's a search algorithm, I guess. Um, returns an iterator. Hmm. To the end of my day, you got oh, mm, 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 mm. You got all my love, where it ain't no cold, and all yours. You got all I want, is the name. You got all I love. Hmm, 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 hmm. Hmm. How to return the index of an element. So I just find, copy, copy is a sorted run, right? Copy, I'm looking for copy, and I'm looking for, what exactly am I looking for? I'm looking for the index of the first element. First element is nums, right? Mm-hmm. Yeah, I return B. To the end of my day, you got all my love. Mm, You got all my love. What? Is no pushback? Oops. What? Ooh, la 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 la. Dun, dun. Whether it rains or pours, I'm on. You've got all my love, wherever it remains. Hmm. Okay, so mm, 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 mm. It remains. Got all my love. Bruh. Okay, is there an easier way? Is there an easier way to do this? It's an easier way to do this. To do this, the sort is n log n. This find is, I don't know what. Hash map, reports. Okay, yeah, I mean, my solution is not the best. I mean, it works, but it's not the best. But, okay, so what are the two that I did today? This one, right? 561. I did this by returning the every second element. And I fucked up the for loop here, so somehow okay. But I didn't actually implement any sort. Like I just sorted it and then I like yeah. Um I can show a little bit of my actual sorting stuff. Oh shit, it's on my second computer. Yeah, but pretty cool. Pretty cool. I understand that. I just draw on here. Uh, let's go to like paint. Right, okay, just go paint. I'm just going to talk a little bit through the algorithm itself so I get a better understanding of what's going on, I guess. So understand there's like the original array, right? There's the original array. And then let's say the elements are like 1, 2, 6, 100, 94, 63, 50, something like that. I don't know. Then you'll create another array, which is much bigger, or vector or whatever. Probably vector, to be honest, because it's easier to manage. That is the size of OG, right? This would be count. And then this would be the size of max, which is 100 in this case, plus 1, right? So this will be 100. Let's say this is the index, right? 99, 98, blah, 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 plus 1, which is 0, right? And then what you would do is you would iterate through this list, through this vector, and then for every value 1, you would increment the value of index 1 at the count vector. So let's say you see 1 here. These are all initialized to 0, right, by the way. So you would add 1. You see 2. You would go to index 2, add 1. You see 6. You would go to index 6 and add 1. You see 100, add 1. 94, 7654, you add 1. Blah, 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 right? And then what you would do is you would add the values here. So 0 plus 1 would be 1 cumulatively. And then 1 plus 1 would be 2. 2 plus 0 would be 2. 2 plus 0 would be 2. 2 plus 0 would be 2. 2 plus 1 would be 3. 3 plus 0 would be 3. Like blah, 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 right? Add it all. And then what the result would be the position of every single would be the position in the output array of that particular index as a value. Like, just so simply what you would do is you would create another array, which is called output, right? And then you have 1, 2, 3, 4, 5, 6, 7. Same size as the original array. 1, 2, 3, 4, 5, 6, 7, right? And then for every number you have here, for every number you have in the original array, you would go into the count array and then insert into the output array. Let's say you're looking at 1, then you would go to count arrays index 1, and then you would insert number 1 into which position? Into value minus 1 position, into value minus 1 index. So this is 1, so you would insert number 1 at 1 minus 1 equals to index 0. So you would insert number 1 into index 0. So this would be 1. Let's look at 2. You're looking at 2 now. So you go to index 2, and where are you inserting into the output array? At index 2 minus 1, you would insert number 2 at index 1, 2, right? There's 0, 1, 2, 3, 4, 5, 6. And then you look at number 6. Number 6 is, so where would you input number? You would go to index 6 of the counting array, and where would you insert number 6 into the output array? You would insert it at index number 3 minus 1 equals to index 2, right? Number 6. You go to 100. 100 would be how much? Would be, okay, you add up 3, blah, 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 and then you get to 50, you would be at 4, right? 63, you would be at 5, 94, you would be at 6, 100, you would be at 7. So 100, this would be 7. Then you would go to index 100 of the counting array. And where would you insert number 100 into the output array? You would insert it at index 7 minus 1, which is index 6. And then hopefully it becomes clear what you're kind of doing. This would be the result of the sort. But clearly, with negative numbers, I don't know how to do, right? What if there's like -1 in here, right? Then what the fuck? Then what do you do? Then what do you do, fam? Right? Yeah. That I still have to learn. Yeah. So I do want to go through the quick sort as well. So for quick sort, what's going on? You're here, you have a bunch of numbers, then you choose a pivot, right? And usually, like if you're safe, you go for the median of 3. You randomly choose like 3 elements, and then you choose the median of these values to be the pivot. That's the safest route, but the lazy route, what people just do is you take the last element, right? And then you compare the first element with the last element. You compare the first element with the pivot value. This would be equals to pivot value. You compare, Jesus. You compare the first element with the pivot value. And I think there's an I and there's a J pointer, right? Yeah, there's an I and there's a J pointer. And J moves every single iteration. So compare this and pivot. Wait, let me just make sure. There has to be 2 pointers. I just forgot where it starts pointing from. Let me look at my notes. Let me look at my notes. Quick sort. Right? Okay. So what you would do is you have an index, a pointer J, pointer I, and then you compare index uh J with index I. You compare index I with the pivot value. And if it is smaller, then you swap I and J, and then J moves. J will move to the next. And then you will compare I with pivot value. And um, if I is smaller than pivot, then mid. Yeah, and then J just keeps moving, keeps moving, keeps moving. And the I only moves when you do a swap of like I and J. I'm pretty sure that's how it goes. Um, yeah, and then you would have uh, yeah, and then you would recursively call this on the left array and the right array, right? That's pretty much it. Yep. Sorry, como. Um, yeah. But this partition algorithm is the key to the quicksort. And this guy does a great example of demonstrating this. 七九三二六, right? Okay, let's illustrate this. 七九三二六. Okay, if I call partition on this, pivot would be 6, right? I, J. So 7 is bigger than 6, so it switches, but it switches among itself, so useless. Sorry. You switch only if it's smaller, right? So if this is bigger, then you would not switch, and then J would move to here. Bigger, no switch. J will move to here. Oh, it's smaller than 6. So what would happen is this would be 3, this would be 7, and I would move here. J would now move next. Oh, smaller, 2 and 6. So these two will switch. 2 and 9. This will be 2. This will be 9. Finally, J, I will also move. And then J will be here. And then J is at the final pivot spot. And then what happens is J will switch with I. Finally, right? So they will switch. And then now it's partitioned. All the smaller ones are on the left, all the big ones are on the right. And then you would call quicksort on this and partition on that. And then, right? Simple. Let's do another one just for the sake of it. Let's go longer. Let's go like -4, 5, I don't know, 2, -26, 50, number 6. I don't know, give me a random number. Well, I don't see any random numbers here. 126. Any random numbers? Let's go 699 and -7. I don't know. Okay, so what would happen here? I choose this as my pivot, right? -7. And then, okay, so -4, -7. So I'm switching them on myself. So what would happen is I and J would move, right? 5 is bigger than 7. It's bigger than -7. So no moves. J is here, 2 bigger than -7. Again, no moves. Now, -26 is smaller than -7. So there is a move. 5 and -26. And then I would move. J would move. I, J. This is bigger, no move. This is bigger, no move. This is bigger, no move. This is bigger, also no move. So what happens is now J is finally here, and 2 and -7 will move. Right? Still, it's partitioned. Oh, -4 is bigger, actually. Okay, see, this is a very, very poor example of partitioning because this one I fucked up, but it don't matter. Okay, ignore this. So technically -7 should be here and -4 would be here or some shit. But now the groups are very imbalanced. There are 6 elements on the right subarray, and then there are only 2 elements on the left subarray. So this would degrade the performance and make it closer to ON squared compared to ON log n of time complexity. So what we should have done is probably chose like 3 random elements and then took the median of that. The median of these 3, -26, 50, and 126 would be 50. In the 50th case, then it would be there's 1, 2, 3, 4, 5, 6 on the left, 50, and then 2 on the right. So I guess these are just kind of shitty numbers to work with. But yeah, quick revision on quicksort. Might as well do merge sort just for the sakes of it. what merge sort is you have like a bunch of elements E some same muktabat, and then you split it in half. You have these four and these four, right? You split it in half, split in half. You have these two, split in half, split in half, split in half, split in half. Finally, you have 8 individual pieces, and then you call merge back into the original one, comparing sort. So this one will be sorted. These two merge, and then this one individually was sorted. This one will be individually sorted. This one will be individually sorted. Um, yep. And then what would happen is, yeah, you would merge all of this back together, and then you would compare these elements. Um, this one compare this one, and then let's say this one compare with this one, and then yeah, and then you would get this one sorted. And after this one sorts, it will go into the next call, which is uh, this, I think, and then this will go into this, and then this. Like it's just recursive, right? And then sort of merge, and everything merges back together. Boom, you get one big array sorted. That's pretty much it. Yeah, gotta keep going tomorrow. Oh, just some quick revision for tonight. Gotta wake up early again tomorrow. Um, yeah, looking at school. Lots of shit to do. Lots of shit to do. What is this? What is height checker? Sounds kind of interesting. Non-decreasing. So ascending order. Let this order be represented by an integer array. Expected where expected I is expected height of the I student in line. You are given an integer array heights, originally the current order that I students are standing in. Each height I is the height of the I student in line. Return a number of indices where height I is not equals to expected I. Okay. Oh, so I'm only given heights? Oh, okay. So Let the night to music we are. Let the night to music. Mm-hmm. Do what you wanna do. It'll only take me and you to set the night to music. Do what you wanna do. It'll only take me and you to set the night to music. To music we brought. Set the night to music. Mm, 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 mm. Make it even better. 57.87. Nope. That even work? Does. But equals. So copy initialization works best, huh? Interesting. Cool. No need to sort. Because set the night to music we heard. Set the night to music we could. Do what you wanna do. It'll only take me and you to set the night to music. Oh, that's pretty clever, actually. Okay, so array 101. And Then for height, then height, then height, frequency, index height plus plus. I prefer doing this for some reason. Um, and then what? Current height. Yeah. While current height is equals to 0. Current height. So there are no frequencies of that height. There are no frequencies of the height within heights. Okay. And if current height is not equals to height I, mm, and then this would decrease, right? If I'm not mistaken. Mm-hmm. Ah, that is kind of genius, to be honest. Very, very clever solution. So this is actually a counting sort, right? Because here you're logging the frequencies of the account, and then you also sort it. Very clever. Very, very clever. Very, very clever, actually. Yeah, that's smart as fuck. Mm, oops. Boy, what? That doesn't seem right. Oh, it was Java, of course. The fuck am I doing? How do I initialize a new array? How do I, okay, I'll just do a vector, whatever. Vector of ints, and size, and inner size is 0. Jesus, that's so slow. One liner. What a newbie. Okay, I did it. Um, yeah, okay, sure. I did how many questions today? I did 2 questions? 3 questions? 3 questions. These two I got by myself. This one, did I get by myself? How many? This one I didn't get by myself. I used Stack Exchange, right? This one, this command I didn't know how to do. Um, yeah. Okay, well, that's pretty good progress. I did three out of three today. Um, yeah, yeah. All right. Call it a day. Peace, dogs. See you.